to BioVivacious. As you know, BioVivacious is a YouTube channel dedicated to clear fundamental concepts in biochemistry. Now we come to another fascinating aspect of metabolism, that is to write a stoichiometry. So this time I am not getting into the detailed writing of the stoichiometry step by step, but very quickly the whole thing is written here. So not to get worried or panic, let us focus on the first part. So when you have to write a stoichiometry, now we know that we have used acetyl-CoA. So how many acetyl-CoA we used? It's only one acetyl-CoA we used. If we have to make palmitic acid with the 16 carbon atoms, so we know that 7 cycles must happen. So which means 7 malonyl-CoA molecules are needed. Even 7 cycles are happening, so we have used, in every cycle we are using 2 NADPH. So this will be 14 NADPH molecules. This is going to be 14 H plus ions. What will be the net result? We will get one palmitate. How many CO2 molecules will be released? So here it is going to be 7 CO2 molecules will be released from 7 malonyl-CoA. Remember that. And how many NADP plus? It is going to be 14 NADP plus. How many CoA? 7 CoA is here, and this is another CoA, that makes it 8 coenzyme A molecules. Water molecules, 7 cycles, 7 molecules of water. But in the last step we have used a molecule of water in order to release the palmitate release unit. So that has to be minus. So therefore this is going to be 6 molecules of water. Have a look at it. This is the stoichiometry for the synthesis of palmitic acid. It's very important that we need to learn this. If you have looked at in the synthesis of malonyl-CoA, which is very interesting. So malonyl-CoA is ultimately made from acetyl-CoA. If we want to make 7 malonyl-CoA, we have to have 7 acetyl-CoA. 7 round must happen in using acetyl-CoA carboxylase. So 7 CO2 molecules, 7 ATP molecules are needed. That will give rise to 7 malonyl-CoA, 7 ADP and 7 PI. So this is how to make 7 malonyl-CoA molecules. Now let us incorporate this malonyl here. So this whole thing is transferred here, and let us make a summary form. So whatever is common, CO2, CO2, all that is common, whatever is common we will eliminate. So you will come up with this formula, that is totally 7 plus 1, 8 acetyl-CoA molecules. The number of ATP that you require are 7 ATP molecules. This is going to be 14 NADPH and 14 H plus ions. That will result into 1 palmitate, 14 NADP plus, 8 coenzyme A, 6 molecules of water, 7 ADP and 7 PI. So this is the overall stoichiometry for the synthesis of fatty acid, for palmitic acid. Okay, so what we have done in this video is we have dealt with the how to synthesize, the complications involved, and the fascinating story of synthesizing fatty acid, especially palmitic acid, and how it is constantly produced for various purposes which we are well aware of. I am sure that you have enjoyed going through this video in synthesizing and writing the stoichiometry. We will be coming up with the more interesting videos about other aspects of fatty acid synthesis. So keep watching.